All right, guys, we're going to add to our table of contents again. In this video, I'm going to make it a little bit shorter. I just want to talk about rationalizing and what the heck that is. But we are going to add more to this page later. So you might want to leave a little space on here to add a little bit more. So we're going to talk about rationalizing what the heck that is on page 71 and kind of 72. You can put that there, but we'll add more to it later. So on 71, you're going to have this one here. I'm going to show you how to fold that right now. So actually, if you're looking at it on this side, so we have this side here, but we want to look at it like this side. And then we're going to fold the two shorter edges into the middle like this. Like I said in this video, guys, I'm just going to make it short. We're just going to talk about rationalizing the denominator. So just like in general, I feel like a lot of people think that math can be annoying because there's so many rules that you have to follow. Well, unfortunately, this is another one of those little rules that you kind of have to follow. For the most part, I think that math is pretty wide open. You can kind of do whatever you want as long as you like follow order of operations, really. But this is one of those pesky rules that kind of does annoy me. For whatever reason, mathematicians don't like for roots to be in the denominator. They think it's not proper. They think it looks bad. They're just like, we're not going to do it. Okay. So to prevent roots from being in the denominator, we kind of come up with this process called rationalizing the denominator so that we no longer have roots down there. Okay. So for instance, if I'm looking at something pretty simple like this, I know we haven't talked about division yet, but it kind of feels like I can't divide the 3 and the square root of 2. Like, I don't know how to do that. Even if the root 2 wasn't there, 3 divided by 2 isn't great. Like, I mean, that's a fraction. You're just going to leave that. And so the only issue here is that I have a root in the denominator, and that needs to go. So the only way that you're really allowed to change a number is to kind of not change it. I know that sounds weird. All I can do is multiply by 1. Because if I multiply by 1, then I'm not really changing the number. The thing is, though, we're not going to multiply by any old 1. We're going to multiply by a fancy one. We're going to dress this one up, make it look nice, take it out to dinner, show it a real good time. The one that you want to multiply by is square root of 2 over square root of 2. So that's 1 because they would just divide out. And it's a really good one to multiply by because if I do root 2 times root 2, hopefully it makes sense and feels good that that would just be root 4, which is 2. And so no more roots in the denominator. So root 4, which is just 2. Now my numerator, I have 3 times the square root of 2, and I kind of feel like I don't know how to do that, so we're just going to smush them up. So 3 root 2. And then I look here and I feel like 3 divided by 2, if I could divide that I would, but I can't, so I won't. And these ones I feel like I shouldn't divide because one's in a root and one's not in a root. So no more roots in the denominator. Mathematicians can go on living their happy lives with no roots in the denominator. So another quick example, sort of like that, but let's change it to a more fun root. Let's change the index to 3, so a cube root. And this kind of looks a little different. So looking here, I can't really divide the 4 and 5, like that fraction is as small as it gets. And maybe it looks stranger because it's a big root. But the thing is, you can write a root around a whole fraction, or you can write it individually. So if you feel more comfy, you can just rewrite the root over each one. They mean the same thing. You can either do the big root over all of it or individual roots over each number. It's fine. Whatever makes sense to you. And I still feel like I can't do anything because I can't take the cube root of 4. Like, even if I think about birthday caking it, that's 2 and 2. I don't have a group of 3. I really can't take the cube root of 5. 5 is prime. And so the issue here is that I have a root in the denominator, so I need to multiply by a 1. And again, not just any old one. It's got to be a fancy one. And hopefully it makes sense again that I should now multiply by a cube root and not a square root. Like, roots got to go with roots. Like, cube roots got to go with cube roots. Square roots got to go with square roots. I need to multiply by a number so that when I multiply these two, like I can cube root it. And so maybe you're thinking of that number. Maybe you came up with it already. But if not, I think it's 25. And to be honest, I didn't come up with 25 first. So like 25, because 25 times 5 is 125. And the cube root of 125 is 5. Okay. I didn't think of it that way though. What I know about a cube root is that I want groups of 3. Because if I have a group of 3, then I can take it out. And so currently right here, I have 1 5. So over here, if I put 2 more 5s, I'll have a total of 3. So I really just thought of it as, okay, well, I need 2 more 5s, a 5 and a 5, so a 25. Because then if I put it with this one, I'll have 3, which will get me my group of 3 and will get me out of the root. So when I multiply the denominator now, I always like to multiply in chunks. Technically, I have the cube root of 125, or just 5 to the third, because there's 2 here, 1 there, for a total of 3. And since I have 3 of them, and I'm taking the cube root, it's just 5. So cube root and cube undo each other. On the top, though, I do kind of feel like I want to change this to a 25 now. So we're doing like the cube root of 4 times the cube root of 25, because I can multiply those numbers, and that would be the cube root of 100. And you should be wondering, like, can I birthday cake that? And the answer is no. And I know that it's no without even really thinking about it too deep, because if I think about where the 100 came from, it came from 2 2s and 2 5s. So I don't have a group of 3, and I can't really group it any other way. I also can't divide here because this one's in a root and that one's out of a root. So bang, bang. Okay, so those are pretty simple examples when there's one root in the denominator. We got to try some slightly harder ones when there's like 2 numbers in the denominator and one of them is a root, because you still have to get rid of it. We don't want a root at all in the denominator. And really, whenever there's addition and subtraction, things get a little messy about division. So, I mean, we really can't divide any of these things, but we really can't divide any of them because of the plus. And so the only issue here is that we need to multiply by a fancy 1 to get rid of that root in the denominator. And here's our fun little keyword. A conjugate can be so helpful here, because conjugates are sort of opposites. And hopefully it makes sense that if I have opposites, stuff will disappear, stuff will go away. That's what opposites do. And so we're going to take the conjugate of this, which will be 5 minus root 2 on top and bottom. Now, we do have to be a little bit more careful when we're multiplying here, because if I look at the denominator, and for whatever reason, I always like to do the denominator first, I think, because that's where the issue is. So I always work through the denominator first. In my denominator, I really have 2 numbers times 2 numbers. And when I have that, the way we're going to multiply is we're going to FOIL. So typically when you have 2 numbers in the bottom like this, and you're trying to get rid of the denominator, or trying to get rid of the radical in the denominator, rationalize, that's the word, goodness me, you're going to FOIL on the bottom. So we're going to do first times first, outer, which I don't know how to multiply that, we're just going to smush it up. Inner, I don't know how to multiply that, so we're just going to smush it up. And then last, which those 2 are both in a root, so I feel like I can multiply that. So positive times negative is a negative, and then root 2 times root 2 is root 4. Because I'm still thinking about it, I'm just going to continue with the denominator. We'll come back to the numerator, because look at this greatness down here. Your negative 5 root 2, positive 5 root 2, they're going to go. Your root 2's are going to be right out of there. That is 0. And then the root 4 is also going to go, because I know the square root of 4 is 2. And so really all I have is 25 minus 2, which is 23. Now I got to go back and do the numerator. So like when I look at the numerator, I do have to be a little bit careful about how I multiply because I have one number times two numbers, which means we're going to distribute, which usually happens. It could be that you have two numbers by two numbers and you'd have to FOIL again, but luckily not this time. So we're just going to distribute. So 3 times 5 is 15. And then 3 times this, I feel like I'm just going to smush them up, minus 3 root 2. I know we haven't talked about it yet, but it kind of feels awkward to subtract these. And it should feel awkward. Don't do it. We just have 15 minus 3 root 2. Oop. And then my final answer, 15 minus 3 root 2. Now, one thing that you could potentially do is if all of these were divisible by the same thing, we could do it, but they ain't, so you won't. And then let's try another one real quick. So down here, I got to get rid of that root in the denominator. Can't have it. We are going to multiply by the conjugate. So 3 plus root 5 on top and bottom. Now, because we're multiplying by a conjugate, when you do FOIL, you almost don't have to fully FOIL. You can really just do like first and last. The outer and inner should always cancel out. So if we really just want to like be lazy with this, which I'm fine with, we'll just do first times first and then last times last. Conjugates will always cancel in the middle. So your outer inner will always cancel with a conjugate. That's the only time you can do this FOIL shortcut. And so then we have minus root 25, which is actually 9 minus 5 for 4. Then I got to go back and do my numerator. And in my numerator, I am going to distribute. So we'll have 12 minus 4 root 5. Can't subtract them. Feels kind of awkward. Don't do it. However, when I get down here, I notice that they are all divisible by thing. They're all divisible by 4. So we can do that. Like 4 goes into 12 3 times, and 4 goes into itself 1 time. So minus 1 root 5, or just root 5. Huh, that's kind of funny. Like that was my denominator, and that's my numerator. Fun. Weird. Not going to happen. It's not a thing. I just pointed out because I noticed it. It is not a thing. Like clearly, it is not a thing. And guys, I think I'm going to leave it there. Hopefully that seems pretty easy and doable. We will talk more about multiplying and dividing and adding and subtracting in the coming days. So just try rationalizing for now.